So you're saying that the difference between, I love it, sample versus population, yes, acting up. Okay. The proportion, yes. Okay, the proportion, what's the difference between these two? Go. Say it again. Say it again. Okay, and percent of population. What is a sample mean? Okay, what's the population mean? Okay, and then sample standard deviation, like how spread out. Okay, okay, good. And then so your standard deviation is the square root of p minus p times 1 minus p divided by n. I'm taking the square root. Mm-hmm. 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 That's our sample, and it's a portion. It's also called our point estimate. Again, in stats, we like to use a ton of words so we confuse people, right? Yeah. Do what? Yes. So let me get through these and I'll answer that question. Okay, which of the following could be a 95% confidence interval? Okay, so they'll give you a interval, and then they'll say which of the following could be a 95% confidence interval. Do you know how to find that? Mm, sort of, yeah. So you have to use the calculator. Okay. So what's that formula? Okay. So think about all of our formulas. We've got point estimate plus or minus the margin of error, right? What is the specific formula for this? This is the general. What's the specific? Look back in your notes. This is not a trick question. Go ahead. You got part of it. So p hat plus or minus the critical value times the square root of p hat times 1 minus p hat divided by n, right? Okay, yes, this is standard error. Okay, look back at the next question asks you about, we talked about this yesterday with the 4C method, the choose, check, and calculate. Oh my God, I cannot. Say it again. Yep, 4Cs. So it's choose, check, calculate, and conclude. Okay, so if somebody says for you to construct a 95% confidence interval and it gives you like open space to do this, you're going to choose, check, calculate, and conclude. Yeah. Does that make sense? Okay. Look at that previous page and make sure that you understand how to do that completely. So that's on that how much of Earth is covered by water page. Take 2 seconds, look that over. Okay, let's say that I want you to tell me what proportion. If I give you this interval, tell me what the proportion would be from the sample. Okay, add them together and then divide by 2 because it's like finding the halfway point, right? Okay, 0.44. Okay, let's say I was trying to find MOE. If I was trying to find the margin of error and I was given this interval, how would I find it? Okay, so Nova said it. 0.52 minus 0.36 and then divide by 2. Yep. Because you do plus minus? No. Yep. And find the difference, yeah. Because it's the halfway point. Yep, that's fine. It's this, that's the same thing as that formula. Yep. How do you choose the sample size? So right now, the only thing that you've known how to do is one sample Z interval. So that's all you're going to put. One sample Z interval for B. Yes. Okay. Yep. So critical value is the standard deviations. Remember, when we have a curve, let's say that we want an 80% confidence interval. That means that 0.1 is on this side, 0.8 is what we're looking at, and there's 0.1 on this side. Yeah. The critical value is talking about this z-score. Does that make sense? It's from this one to this one. Yeah. Okay, remember, you can put that into your calculator, or you can have 95%, 90% all memorized. Yes. The critical value. Yep. Good. Okay. What would happen to the width of the interval if we increase the confidence level? It would do what? It would get wider. Why? So it would cover more of the data, right? Okay. If you increase sample size, what happens to the interval? Okay. Why? Okay. All right. Do you know all the different conditions that you need? Okay. Large count, random, and 10%. Okay. Say it again. So if we are doing large counts, remember that's n times p, which is greater than or equal to 10, n times 1 minus p, which is greater than or equal to 10. Okay, this makes us relate it to the normal distribution, right? Okay, talk to me about 10%. How do you check for 10%? 10% of the population. Okay, pay attention to how the question is worded. Sometimes it's specific to like a specific school. Sometimes it's talking about completely general. right? Okay, so this relates it back to what? Without replacement, which lets us be binomial, okay? And then the last one is random. Why does that help us? Generalize to all locations. Generalize to all population. Yeah? Good? Okay. So if I'm talking about, let's say, please click. Thank you. Let's say that I'm talking about all right, ask your question again. So I would take 0.10 and I would multiply it times all restaurants. How many restaurants are there in the world? A ton. Are we going to take a sample size that's less than? Yeah, so it'll be less than 10% of that population. Yeah. Okay. Looking at which type of confidence level you have. So if I had, let's say, I don't know how to ask this without telling you. Okay, so let's say that I had 100 kids. Okay, first of all, all right, so we've got 100 kids, and that y'all have 45% perfect attendance for the whole school year. Okay, margin of error is going to be, let's say, 10.5. Okay, which of the following, or which confidence level would work? So these are asking for the percentages. You got 80, you got 90, you got 95, you got 99. So how would you go about solving this one? Okay. How would that help us? Okay. How would you go about solving this? So this is the confidence level. Okay. How would I do that? Okay. Oh, you're talking about, okay. Gotcha. So you're saying 0.45 times 1 minus 0.45 divided by 100 and take the square root. Okay, so what does that do for me? Okay, well, what would that give me? Okay, so try that. Go ahead and try that on your own. So if I tell you that 45% have perfect attendance, there's a sample size of 100 kids, your margin of error is 10.5. Which confidence level should we be using? What would we do? Take a second, think about that one. So what you're going to do here is you need to take your point estimate, you need to add and subtract the margin of error. So 0.45 plus 10.5, what is that going to give me? Y'all got to talk to me. Plus 10.5. Wait, 555? Yeah. There we go. Okay, then we're going to take 0.45 minus 10.5. I'm sorry, 0.1. You get it. Okay, so 0.345. You meant 0.355? There you go. Okay, cool. All right. So now what you're going to do is take this and set it equal to each one of these and solve for your critical value. Your p-hats are all going to be 0.45. Your n is going to be a 100. Okay, so go ahead and solve. Tell me what the critical value is.
Okay, this ask us for like the critical value. Is it a side or is it?
It's like exponent. Mm-hmm. Another way you could do this is you could take each one of your critical values for 90%, 95%, 99%, plug it in and see which one it works for those intervals. So if you don't want to sit there and solve, go the opposite direction. Okay, so you know your critical values for 80, 90, 95, etc. You could plug in your critical value and see if it works for your interval.
So like, if you plug it in, it should be in between. It should be in between the little parts. Wait, what?
Okay, what's the critical value for 95%? Okay, so for this critical value, I'm going to put 1.96. I'm going to put p hat is 0.45. Then n is going to be 100. I'm going to plug all of that in into this equation down here at the bottom on the left-hand side.
Right.
That is going to give me my interval over here. So I don't have to solve. I can just go back and plug in. Like David just lost it.
Okay, so if you put it, no, because if you're doing that, then how do you know what specific interval we're looking for?
You already found the interval, like that one over there. That's the one that we're trying to get because that reflects like what the confidence level and all that already is. We're just trying to figure out like what actual confidence level are we at.
Which one would be most
So you
appropriate?
want us to plug in confidence level until it equals that.
Works for this.
Okay.
But we don't need to find it. It's just I just don't know.
So the best way to do this problem is if you're given a point estimate and you're given the margin of error, find the interval. Then take your critical value and plug it into this formula. See which one produces that interval. Yes? Don't forget about this one. It's not bad. It's just working it backwards. I understand. It's not bad. You got it. You'll be okay. All right. It will be fine. Okay.
Times the one minus the value divided.
For your critical values and the inverse norm, yes. That's how you find that critical value. Okay. The next question is going to be, there's only 10 questions on here. There is a margin of error and you have a certain percent confidence level. What is the smallest sample size that is guaranteed in order to make this work? Okay, so if I tell you, remember, this is the one that we did yesterday. If we are not given a proportion, what do we use? If we're not given a proportion, we use 0.5. Yes? So then we can solve for the sample size. Do we remember that? Now, if like I give you a confidence level I don't give you a sample size. You use the proportion of 0.5. So this just tells us how big or the smallest sample size that we could potentially use. Now, if we have like a proportion, then that's going to change our sample size a little bit.
In sulfur and it won't be bigger than 0.5, but then when these 0.5 for it.
It will be bigger than. It won't be smaller than. This is the smallest. Yes. Good. Say it again. P is 0.5. T is 0.5. That one's not bad. You can do that one. Okay. Most of these are find the interval. It won't take you very long. This should take you about 30 minutes max. Okay. So what I want you to do, go ahead and clear off your desk. Oh God.